Thanks for having me. So again, my name is Jeremy, one of the co-founders of Megapixel. We'll get a couple slides up here. They're coming. There we go. Nice big logo. So we've been in the virtual production space for a number of years, since about 2004 is when I worked on a first feature film using LEDs. And I want to walk through a little bit of kind of how we think about virtual production and where we're going to be going in the future and how we're driving a lot of these things in the back end. This is a still image from Gravity. This was a very early, um, well-recognized film that used LEDs for incident lighting, and so we were driving LEDs. This is actually using a motorized robot arm from Mo-Sys to do all of the scenic elements as well. So this had not only camera tracking and motion, but all the LED environment was able to move with it and give proper reflections on face and helmet and eyes and everything. Um, First Man is one of the first, or actually is the first large LED volumes that was built as it's known today as an LED volume. So this was back in 2018. 2017 is about when we were doing the production, and this was using both film camera, literal film cameras, and digital cinema. So we had a very interesting methodology of how we needed to do color correction and color grading for the wall so that the cameras could see things differently, because obviously film has very different chemistry from the digital sensors, and so this was something quite unique that we had to solve a lot of problems for. Then we have larger volumes that were started to be built more for either episodic or movie making, but being put into sound stages a little bit more permanently. So this is Netflix's stage for 1899, built at Studio Babelsberg. And you can see, interestingly, a lot of photos and environments that you may have been in for virtual production. Very often there's an LED ceiling. And in this particular production, they did not need a ceiling of LED because there weren't a lot of reflection shots. They needed environmental lighting, but they didn't need reflections off of like the glass on a car or something like that. So traditional lighting was used overhead. And so this mix is also really important, because I'm going to get to why you may want to mix lighting and video together. And then we've of course worked on a lot more projects. I'll thumb through these a bit more quickly. Another stage that we executed that's very large, called Trilith in Atlanta. Nant Studios is actually the largest in the world. This is using all of our processing infrastructure, and it's all network based. So there's a massive network that's capable of running about 2 billion with a B pixels in this space. And this comes into broadcast as well. So we've done a lot of bleeding edge things for virtual production. All of these things are generally not needed to necessarily be real time, because they're all recorded to disk, and then there's post production and editorial things that happen afterwards. Fox NFL Sunday that we executed a couple years ago is actually live to air, and so this is a really good example of how virtual production technology and all of the tech that we bring together, not only on the LED side and the processing side, but with cameras and tracking, is really important. So this is a 4-camera shoot. All 4 cameras are simultaneous, and so there's 4 rendered views from Unreal Engine as well. And as they cut cameras, each camera is able to see its correct view. And we're using a technology of ours called Ghost Frame here, where the talent actually feels like they're in one environment, not 4, but the cameras are able to see all of their individual feeds simultaneously. ESPN just implemented very similar setup to Fox Sports, um, also using 4-camera feeds. And this is another Unreal Engine setup, and it's able to capture multicam, which is again taking a lot of these virtual production techniques from cinema and moving them into a broadcast space. So kind of taking a step back, one of the things that we started looking at is not only where we've done virtual production and broadcast, but also some of the large architectural applications that we've done. This is an image from MGM Cotai. This is an enormous amount of LED in this space. And you may look at this and you say, well, why do I care about this related to broadcast? Well, this is an enormous amount of physical LED rasters, and we have to manage all of them, and we need a fiber network to be able to carry all of the data to equipment racks and screens and different IT closets and things like that. And so when we think about the tech that we're building, we want to be able to run everything on networks and be able to join different displays and different pieces of metadata across any kind of network. And that works just as well in a large building lobby as it does in a broadcast space. And so we're able to kind of think about a lot of the reasons of why do we want to move pixels around and why do we need so much bandwidth? Well, it's applicable everywhere. It's not only this particular need. So I've got another just couple nice photographs that we can see that we've been implemented. So again, very similar technology to what we would be using here, for example, but this is proliferating beyond the studio and getting into these immersive spaces as well for architecture. So how are we doing some of these things sort of behind the scenes? Let's look at our Helios processing platform. That's what's driving this this booth here. It's a 1RU appliance. We've recently introduced a 100 gig QSFP module. So this is able to take 100 gig fiber natively into the LED processing system. What this does is it gives you basically 8K rasters times 2, so that you can have a main and a backup, or you can stitch multiple rasters together to do panoramic and larger formats. We've just won an Emmy Award for this. We'll be accepting our trophy in October, so we're really proud of it. And this is all network based, not only on the input side, but on the output side as well. So we have 8, 10 gig fibers. Those can spread all throughout a building. So that imagery that I showed of the architectural installations could very well be different locations in a building, different locations on a campus, different locations within broadcast facilities, campuses, studio lots. All of that for us is kind of the same because we're basically putting all the payload over the network. Okay, let's advance one. So one of the things that drove us to wanting to go network based rather than being baseband, and also rather than being proprietary in terms of all the interconnect and cabling, is that when we look at a typical system of video that might be deployed with HDMI or SDI, we have things like a NAS or cloud content. We have a server. We have a video router. We have the LED processing and all these other things. And everything is serially connected, which means that each one of these arrows that I have here is an interconnect, but it's also a metadata failure point, not just a video failure point. So what that means is that if we have a metadata failure, we may not necessarily stop video transmission, but we may have the wrong content being put on the screen. As an example here, I've had Rec 2020 versus 709. Both of these are broadcast standards, right? One of these is not wrong versus right. It's that they're different and they apply differently to SDR versus HDR content, et cetera. So what that means is that if you have a metadata failure point at anywhere in the system, you may not know which red you're supposed to be displaying. People have preferences, of course, but that's a style thing. That's not a correctness thing. So we want to make sure that all of the data is coming all the way to the display and actually lighting up the pixels correctly. So when we move to SMPTE 2110, what's really cool about that, next slide, please, is that everything in the system is connected to an Ethernet switch. And that effectively functions as the video router. And that means that every single device can talk to every other single device and know what it's supposed to be doing, rather than guessing if it's not receiving that information correctly. Okay, we'll go to the next one. So in our processing system, what's really cool also is because it's on a network, it's all web-based. This means that you can control things with your phone, a tablet, any kind of computer. You don't have to install software. We even have game controller support, which makes it a lot of fun to operate. But the main thing here is that we have concurrent multi-user support. So this means that somebody can be doing color correction, somebody can be doing mapping, somebody can be doing tone mapping, and you can even, because of the pixel capacity, you can drive multiple displays off of one single rack unit. That means that you can have multiple operators operating different screens all logged into the same system. This is very unique and very, very powerful as well. Next slide, please. This is a user interface just showing, again, metadata tools where we can automatically detect the gamut because we have metadata coming in on that signal path. All these color controls are all real time and bidirectional, so that not only are you controlling the display, but other people can also be grabbing that metadata and understand what the display is doing at the time of capture. This is incredibly important for post-production VFX, for example. So this is a great example of why do we like these networks? Well, we want to combine not only the metadata and the video signaling for getting great video across, but lighting should be included as well, because all of these things we like to treat as pixels. And so this is a lighting fixture that we co-developed with KinoFlow called Mimic. They're in Hall 12 if you want to go see this product. This is a 5 primary LED tile, so it's red, green, blue, and then 2 color temperatures of white. There's a 2700 Kelvin and a D65 Kelvin. This gives very beautiful broad spectrum illumination. So this is meant not for being a video screen to look at, but it's for illuminating skin tones and objects that would otherwise be very difficult to reproduce proper CRI and proper colors on. We're able to drive this off of the video system now. So Helios will drive not only the backdrop and everything in the studio, but it now also can drive the actual lighting fixtures themselves. And sometimes people will prefer to drive this with video. Other times people will want to hook up a lighting console and say, I want streaming ACN control over these fixtures. And we actually, because of the 2110 network, we're able to merge these. So we're actually taking the lighting data and the video data, we merge them together, and you have additive and subtractive color mixing control on top of the video layer. So this is a really, really, really cool thing. And we see a lot more of this coming in the future, of just being able to combine a lot of different technologies into a singular control system without taking away the ability for each department to control the device the way that they've traditionally controlled it and the way they like to control it. Next slide, please. So extending beyond this, now that we've got our base layer, we've got our studio, we've got our cameras, we've got our lighting, we've got our LED backdrop. This is all great. It's a wonderful ecosystem. But now we want to take it a step further. We want to be able to control things remotely, just like this camera is moving around like a robot. Why can't we control remotely the display as well? And maybe I'm sitting in an office and I want to control this, 20 locations around the world, not just something that I'm an environment that I'm sitting at. So next slide. So we have a new offering that's built on top of Helios. Every Helios that has been created since 2019 is able to cloud connect directly. So you can look at geographic regions that are connected. So everything gets consolidated. You can get beautiful dashboard views of status of LEDs. You can understand whether colorimetry is coming in correctly for all of these locations. Next slide, please. And then there's a lot of notifications as well and a lot of security measures. So that means that you can have analytics running, but you can also have very specific access control for who gets to see these analytics. Next. And then on top of that, we have an on-prem version of it that we call Omnis. I've got just a couple slides on this, and then I'll take questions. So Omnis, next slide, please. This is giving us management control and a single pane dashboard for large campuses as well, for on-prem usage as opposed to cloud. So this is an extension of the network. This device is able to give a single pane view of not only all of these mega canvas surfaces, but also all of the networking infrastructure that's driving it. Next slide, please. So we've implemented both Helios and the on-prem Omnis for Eurovision. This is a great example of a lot of different types of technologies all in one place that we get to aggregate and monitor together. This is a video of the previous picture that was up there. This is MGM Cotai. Again, this is one of the world's largest LED installations under one roof. It's about 250 million pixels, 27 4K rasters, incredibly complex to manage content for. Next slide. So very quickly, here's an image of just a few of the walls on the side. We've got a lot of processors on this particular project. Next slide. And this is our processor mapping. So it's a little bit less useful to see a list of 10 processors. We want to understand how are they interconnected and how are they related to each other spatially. Next slide. So We have a single pane dashboard view that shows us all of the individual processors, but how they're physically laid out. So the software UI looks exactly like we see in physical space, and we can even pull up heat maps. All of this information is bidirectional. So that means that an HVAC system in the building can decide that the wall might be running too hot or too cold and be able to throttle things. And it really, really ties it all together as a fantastic system. So that's what I have to say. I'll take any questions, and thank you very much.